we are going to deal with something. So you're going to need graph paper to write, or notes to write this on. We're dealing with t-scores, and I'm not really going to talk about anything about what a t-score is. I'm just going to talk about how to read the table itself. We can do that in 10 minutes. All right, we've got 3 things on our graph. One thing we've got is across the top up here, it says tail probability. But on the bottom down here, it says what? Confidence level. Well, both of those correspond, but we haven't talked anything about tail probability, and we have talked about confidence level. So we're going to use the confidence level part. And then over here on the left, we've got this thing that says DF. DF is degrees of freedom. And I will talk more about that later. But what it is it's like compensating for error because we're using one variable. We're estimating one variable. So your degrees of freedom is n-1. That's what you need to know for today. So using this chart, I want you to find if your sample size is 15 and we want a 90% confidence level, then I go look at the bottom at 90. I need to do what with this number? Subtract 1, so my degrees of freedom is actually 14. So when I go down to 14 and I go over to 90, I get what? $761. So reading this table is extremely easy. That's all you do. So like if the problem says, here's a mean, we don't know the standard deviation of the population, which is going to be more likely, more realistic. If we don't know sigma, then what's our best guess going to be? We don't know the standard deviation of the entire population, but what can I probably figure out? Standard deviation of the what? Of the sample, which is what? So if we don't know sigma, and we have to use this from our population, that's when we use a t. That is the exact same thing as a z-score. But it's a little bit different. And I'll talk about like the differences and stuff, but in 10 minutes it'll be easier to just talk about how to read this. The really good thing about this is as your sample size, it's hard to talk about this really quickly without talking about everything. You've got a z-score or a z curve, and that always looks exactly like this, right? A t changes. A t could look like this at some point. It could look like this at some point. And the size of the sample is going to change where that distribution is. But what happens, and I'll give you notes on this, but what happens is as your sample size gets bigger, it gets closer and closer to the z. So what on here is going to help us with as it gets bigger and bigger? As your sample size gets bigger and bigger, what on here would kind of help talk about as it gets bigger and bigger? Being what? Infinity. So if it gets bigger and bigger, well, big as it can, what is a 90% confidence level for a t at sample size infinity for 90%? Why should that be a lipo?
Oh, it's the same one as. Oh, word? Oh, yo.
So the bottom line of this is your what? Z-scores. Now, if I ask you something like, what is the Z-score for 88%, you'd have to know how to figure it out. But if not, they're all right there. Like the ones we use most of the time are 90, 95, and 99. Well, 90 is 1.645. 95 is 1.96. 99 is 2.576. So those Z's that we had to do the other day where we had to do this and divide it by 2 and subtract it from 1 and that kind of stuff, most of the time you won't ever have to do that because we're going to use these on here. And you'll memorize them anyway. So it is very helpful that those are down there.